Hey there. Today what you're going to learn is different types of waves. We're going to look at four main types of waves, and what I'm going to have you do is there's a couple videos here. This video here is you'll see a bunch of these about the Comaneros Bridge. Maybe look at that. This video here is a little bit longer, but it's got a few important times in there that I'd like you to look at. A lot of information that you don't necessarily need. There's some questions I would like you to look at, wave types of questions, and that's what you're going to submit to me. But in order to answer those questions, you're going to have to know something about some types of waves. Okay. The couple links here at the top are a couple different simulators that we will look at here to help you understand different types of waves. But here are basically the notes you're going to want to have for these topics. We got four types of waves we're going to look at. We're going to look at the transverse wave, longitudinal wave, surface wave, and torsional wave. There are other types of waves, but these will cover most of the types of waves that you're going to want to know. Okay, so the first type we're going to look at is a transverse wave, and the key for a transverse wave to understand them, to any types of these waves, is how does the medium move relative to the wave direction. So if the wave direction is moving right to left, what's the medium doing? So in a transverse wave, the key phrase is perpendicular. So I'm going to use this symbol there, is that the medium always moves perpendicular to the wave direction. So if the wave is moving right to left, the medium might be moving up and down. They would be perpendicular to each other. Okay. Now, an example of that would be light. Light is one example. There's also many mechanical waves that do this. Many mechanical waves will do that. But light is also a transverse wave. We're going to look at a couple of simulations here. Here's one simulation, and for a transverse wave, if you look at this simulation, if you look at any particles, the particles are simply moving up and down, but you can clearly see that the wave is moving from left to right. So the wave is moving left to right, but the individual particles are moving up and down. That is perpendicular. Second type of wave is a longitudinal wave. Now, one of the classic examples for a longitudinal wave is sound. Sound is a longitudinal wave. And what we say is that the medium moves parallel to the wave direction. Okay? Longitudinal waves are horrible to draw. No one wants to draw longitudinal waves, but we're going to look at a simulation here. Here is a simulation of the longitudinal wave. If you look at any of the red dots, you'll notice although the wave, you can follow the wave, the compression or rarefactions are moving to the right. The wave is moving to the right, but the individual dots are not. You look at a red dot, it's simply moving right and left and right and left. So it is moving parallel. You can see that in both these diagrams here. Look at a particle and you'll see where the wave is going and how the particle is moving. So we say that in longitudinal waves, they move parallel. The medium moves parallel to the wave direction. Now, a surface wave moves both perpendicular and parallel. So it actually kind of a circular motion. There's some different types of these. A couple examples of that would be like an earthquake and water. Okay. Let's take a look at the simulation here. Here's a couple different types. And so you'll see here with the water wave, if you look at the particle, it's going both up and down, which would be perpendicular. The wave is moving to the right, and it's also moving left and right, which would be parallel to the wave direction. And that's what gives you kind of a rocking or a rolling motion. They say, like, if you're in a boat and you're hit by a wave, it kind of rolls. It doesn't just go up and down. A lot of people think that water waves are transverse waves and you just go up and down. No, you actually go side to side as well as up and down. Also, you'll notice that Raleigh's surface wave you'll notice it's a little bit different, but there's some similarities in the fact that it's both going up and down perpendicular and it's going parallel. Now, the last type of wave is also a tough one to draw. It would be what we call a torsional wave. And a torsional wave, what we might say is that the medium rotates about the wave direction, okay? And there's a lot of there's certain mechanical systems that will be an example of this, where the medium will rotate. If you twist a rope, that twist will travel down the rope as a wave, okay? In order to look at this, is a tough one. I got another simulation here. And we are going to look at this. And if you look at the blue dots or the red dots, you might think, well, they're just going, the dots themselves are going up and down. It looks like a transverse wave. So if I change the perspective, you say, well, those dots, those blue dots are just going up and down. Well, and the red dots are going up and down, but you'll notice the medium is really the black line in between. And what's happening is that when the blue dot of one end of the black line goes up, the red goes down. And so that black line, which is what we consider the medium, is actually rotating. Although the wave is going side to side, the ends are going up and down, but they're going opposite. One goes up, one goes down. So it's actually, the medium is actually rotating about the wave direction. Okay. So these are 4 types of waves: transverse wave, longitudinal, surface, and torsional. And even though we talk about 4 different waves, when we draw the waves, we're always going to be drawing a wave. It's so much easier just to draw a wave that looks like this, which in essence is like a transverse wave. So even though we might be talking about sound, we'll draw a picture like such. Now, when we have a standing wave, you have constructive and destructive interference. Once again, we've talked about this before, we get nodes, which are the regions of no movement, and then we get antinodes. And those are the regions of big movement. And what I want you to do with the questions, watch the videos, is being able to identify in the video, when you look at the Tacoma-Narrows Bridge, what type of waveform is going on. 2 different types of waveforms. It'll start with one type of waveform, and then it moves into another type of waveform. So the question is, do your eyes and your brain, can you identify the different waveform? And then can you identify the nodes and antinodes? Where are they? And can you draw a diagram? That's what I want you to be able to do. And you'll be able to do that over here on the questions that I'm going to ask you. Okay, so you have the questions and look at the videos.